Hello everyone, welcome back. Let's move on to our next question. ABC is a plane lamina of a shape of an equilateral triangle. DE are the midpoints of AB, AC and G is the centroid of the lamina. Moment of inertia of the lamina about an axis passing through G and perpendicular to the plane ABC is I0. If part ADE is removed, the moment of inertia of the remaining part about the same axis is given as n I0 upon 16, where n is an integer. So we have to find out the value of n. Now I am giving you 5 seconds to read out this question and then I will move on to the solution. So now let's check the solution. We can say if m is the mass of the lamina and I is its side length, then the moment of inertia of the lamina about an axis passing through G and perpendicular to plane is I0. Let I0 equals to kml square and IDEF equals to km by 4 l by 2 whole square, and this is also equals to I0 upon 16, and the inertia about ADE is equals to inertia upon BDE and EFC, and let this inertia is equals to I. Then 3 times of I is equals to I0 minus I0 upon 16. That implies 3I equals to 15 I0 upon 16. Then solving this equation we get I equals to 5 I0 upon 16. So we can say the remaining inertia is equals to 2I plus I0 upon 16, and solving this value we get 11 I0 upon 16. So we can conclude our answer by saying that remaining inertia is equals to 11 I0 upon 16. Hope you understood this question well. See you in the next question.